mess with the shape of the graph. Okay, so today's lesson is just about doing 1 and 2, but doing them at the same time. So if you're doing a reflection, it is technically a stretch because you're multiplying by a -1. It doesn't change the values of, well, it does change the values. It ends up resulting in a reflection. So stretches, compressions, and reflections all get done together. And the last thing that you're going to do is do your translation. So that's your move. So these are your moves. And these all happen because you're multiplying them. Okay, that's also crappy. All right. Okay. So let's put it together. Now, the reason why this is given in function notation is because there's no, I don't know if you guys can see that okay, but this is that's your graph right there. That's your f of x graph. There's no equation that's going to go with it to make it beautiful or to follow a certain thing. So the first thing I'm going to do is I'm going to do a table of values. So I'm going to pick some critical points. And again, the critical points are just, I call them critical, but they're just points that are nice and easy for us to like pinpoint. So let's do that. So this is going to be -2, +2, and then I have a -1, +2. I have a 0, 1, a 1, 1, and a 2, 1. So those are all the points that I've grabbed. It's pretty exciting. All right. Okay. So now that we know that, that's the first thing I'm going to do. So if I don't have a function, it's kind of like I always default to my table of values. So this one's telling me a couple of things. What does that 2 tell me to do? Times the y by 2. Times y by 2. Then what does that -3 tell me that we're doing?
Add 3 to the x.
Add 3 to the x. Add 3 to x's. And then this subtract 2.
Take away 2 from the y.
Yeah. Subtract 2 from y. Now, I actually do this every time. Okay, maybe I don't do it every time. That might be a little bit of a stretch of the truth. I do this when I'm learning how to do it, is I label them, because it helps me know what the next step is for the math. Now, let's change this into a mapping rule, because the mapping rules tell us what we do with our math. So the mapping rule starts with an xy. This question did not ask for a mapping rule, but I just thought it might be handy. What am I doing to my x's?
So you're adding 3.
I'm adding 3, so it's going to be x plus 3, because it's the actual math, right? And then what am I doing to my y's?
Timing them by 2 and then subtracting 2.
Sorry, didn't leave myself enough room. So if I look at it like that, it makes a lot more sense when I do my mapping rule. And guys, this question didn't ask for it, but sometimes I find that makes it easier for me to see. So now I'm just going to do my new table of values. And what do we anticipate this graph looking like? We know that it's going to be taller, right? Because it's got the stretch, the vertical stretch of 2. Do we expect the graph to be any wider? No, because there's no horizontal stretch. What is there? We're picking it up and we're moving it 3 to the right and 2 down. Does that make sense to everybody? So you're looking at a taller graph, same width, taller graph, same width, that we're going to pick up 3 units to the right, 2 down. And I suck at visualizing, so I hope my math is better than my visualizing. Okay, so I'm just going to squish this down a little bit. Here's my original table. So for the x's, the only thing I'm doing is I'm adding 3. So that's going to be 1, 2, 3, 4, 5. All I did was take these values and add 3 to them. So negative 2 plus 3 gave me a positive 1. Negative 1 plus 3 gave me a positive 2. Does that make sense to everybody? So that's the only math I'm doing here. Now here, the y's, I times them by 2, and then I subtract 2. So 2 times 2 is 4. Here, let me just write this one out. So 2 times 2 minus 2 equals 2. And I'm a pretty smart kid, so if this one was a 2 and this one was a 2, this will also be a 2. So now we've got 2 times 1 minus 2. That should give me 0. And so all of these are going to be 0. Because those are all 1s, right? Does that make sense to everybody? I'm being more efficient. I'm not doing the same calculation, the exact same calculation over and over and over again. All right, okay, I'm going to try pink, but it might not work. Okay, so we're going to lay these points down. So I'm going to be at positive 1, 2, 2, 2, 3, 0, 4, 0, 5, 0. All right, so if I look at this graph, how tall is this graph here, from here to here? What's the height of the graph? 1 unit, right? Like if I look at the height of the graph, this is the lowest point, this is the highest point, it's 1 unit. If I look at this graph, it's 2 units on this one, which makes sense because we anticipated it to be a taller graph. The width of this graph goes from negative 2 to positive 2. How many units is that? It's 4 people, it's 4 units, right? From negative 2 to positive 2 is 4 units. If I count them over, 1, 2, 3, 4. And if I do that here, 1, 2, 3, 4. The width of my graph did not change. Right? And those were things that we anticipated. And the reason why I'm saying it over and over again is so that you have ways to check to see if your math is making sense as you go. So we've doubled the height, we've kept the width, and we shifted this 3 to the right, which makes sense, because if I take this point, if I just look at this point, I went 3 right. 1, 2, 3 should be here. And I'm going to go, how many down? 1, 2. But the down is affected by the stretch, so that point doesn't translate exactly. All right. Okay, so next one. Again, going back, going to label it. What does this negative tell me to do?
Reflect on the x-axis.
Reflect on the x-axis, so it's a reflect on x-axis. That's nice, because that tells me what I should see, but mathematically, what does it tell me to do?
Times by negative 1.
What times by negative? So the y's times, and that makes sense, because it's out in front of the f. The 2 is out in front of the f, and we times the 2 by, the y values by 2. We're timesing the y values by negative 1. And this one, you're going to take the x's and we're going to times by 2.
You have to do the...
You got to do the reciprocal. Right, perfect. So again, I'm just going to do that table of values. My original table of values is right here. So my x's I'm going to times by 2, so that's going to be negative 4, negative 2, 0, 2, and 4. And so what we anticipate is a much wider graph now. Is the height going to change on our graph?
No.
No, because we're timesing it by a negative, but it will be
Upside down.
upside down. So now we're going to take our y values and times them by -1. So I've got -2, -2, -1, -1, -1. So I find the table of values, and I will say this time and time again, I find that the table of values really does help me. Does help me in figuring out exactly where I should be. Some people are really good at the visualization, and they can see it and they can do it in their head. And I applaud you if you were that person. Keep doing that. Like, don't feel you've got to do the table of values if it doesn't make sense to you. I'm just trying to do it with training wheels on, because, you know, it's hard. -2, 0 and -1, 2 and -1, 4 and -1, so there, to there, to there. That looks a little funky, but we notice that the height of this graph, the lowest point is here, the highest point is right there. The height is still 1. The graph has a height of 1. And now the graph has a width, it used to be 4, this graph has a width of 8, which is double, which you would anticipate because we're multiplying everything by 2. We good? Nobody's crying, this is a positive thing. Alrighty. Okay, so now, you've always been given the equations, but now we're actually going to write the equation for it in function notation. Again, this is an absolute value graph, I can tell you that. Which one do we want to be our original? Do you want the big one or the little one to be the original? The big one? Okay, so this is our f of x, and this is our transformed graph. Alrighty. Now I want to point out that these points translate to those points on the graph. Now it just looks like I have some wide-eyed creatures. So those are the points that I'm going to be talking about. So the first thing I'm going to deal with is, I'm going to look, are there any reflections? How would I know if there's a reflection?
It would be looking, it would be upside down.
It'd be upside down if it was reflected in the x. This one's kind of hard to tell if there is one, because it's, notice they're all symmetrical.
Yeah.
So we're going to say that there's no reflections. So I'm going to deal with my stretches first, right? Because that's what we were told to do. So my stretches.
Is there a parent function in this? Because I don't see a one that says, so I'm not sure which one is our...
We decided, Kai picked it, and he said that f of the wide one was going to be our f of x.
Okay.
Life choices were made. Just happened. Okay, okay, so let's talk about our stretches. We know that it's kind of gotten more narrow, right? So our x's, something's changed on our x's. So let's look at the distance between these 2 points. So -4 to +4 is 8 units. You guys would agree with me? Yes? And now looking between these 2 points, and I'm going between those 2 points because I know they've been translated. Now that's down to 2 units. So what has happened?
Stretched.
But compressed? Yeah. So let's talk math-wise. What happened mathematically to get from 8 units wide to 2 units
It
wide?
would have to be times by 4, the x, but it'd be the reciprocal, so it'd be times by a quarter?
Yep. Really, essentially what we did was divide by 4, right? We took 8, divided it by 4, but we're going to talk about it in terms of multiplying. So we took the x values and we times them by 1/4,
Yeah.
right? Okay, let's talk about the y values here. Trying to switch colors, but I don't have a lot of colors that show up. So if we go from here to this height here, that's a height of 4 units. And if we go from this one here to those dots, this one has a height of 8 units. Okay, so my purple looks exactly like my black. All right, that's not very exciting. Okay, so what happened to the y's, mathematically speaking? We were at 4, and now we're at 8. Times by 2. So y values. And again, like you guys, some of you are going to pick up on this so quickly, and some of you are going to be like, I don't see it. If you're like that, I don't see it, welcome to my group. If you're the advanced class who can see this and visualize, that is awesome and amazing. I, unfortunately, do not have that gift, okay? So it takes me some time to work through it. All right, so now that we have that, okay, I keep getting these phone calls. There's somebody calling me right now it's a 679 number, and they're all about my social insurance number. There's an action against my social insurance number, but they're all Thompson numbers. Like they've pirated a bunch of Thompson. Anyway, that's my life right now, ladies and gentlemen, is I get phone calls on a regular basis. Okay, so would you guys agree? So A is what gets times by the F. So we would say that A is 2. Right, you guys with me so far here?
Yes.
All right. And B is what's times by the X.
At 4.
B is 4, because you have to do the reciprocal. Remember that this is the math. We just talked about the math. Now we have to put it in the right form. Okay. So the moves, the shifts, are a little bit different. Okay. You have to pick a point that will not be changed by the stretch. So if I'm looking at my vertical shift, if you're looking for your vertical shift, what's the only value that will not be affected by multiplying it by something? 0. So the vertical shift, you're going to pick a point where y equals 0. Are you guys okay seeing that? Is that coming up okay on the screen there? Do I need to shut the window? Like, is the sunshine? No. Okay, just double checking. Okay, so there we are right there. Y equals 0. Because y equals 0 is, when y is 0, if you multiply that by 2, it's still that exact same point, right? It's not influenced at all by the stretch. So, and if you're doing a horizontal shift, and FYI, they don't have to be the same point, but this time it actually works out okay. Pick a point where x equals 0, same reasonings apply, is that 0 is the only thing that's multiplied and it still stays 0.
What if you have a graph that doesn't have x at 0?
Then what you would do is you would apply the stretches, like let's say I would apply the stretches to here, and then so stretch them, and then move them.
Okay.
Right, so we do them, so I would apply, so if this one's at 4 and 4, like this point's 4 and 4, and I know it translates over here, I'd do my stretches, so this one would be 1. This one would translate to 1 and 8. So over 1, up 8. Now I've got to get to its matching point. What do I got to do to move over and up? Okay, so that would be the strategy if you didn't have a point that had 0, 0. Everybody catch that? Cam asked a really good question about,
If you don't have,
Cam, you broke my
you don't
computer.
have a point that is at 0.
If you didn't have a point that had x is 0, or it wasn't obvious, it wasn't nice or anything like that, just take one of your points, so this one's at 4, 4, and then do your stretches. Do your stretches. So that would transform to there, right, if I just did my stretches. So my x's would be multiplied by a quarter, which takes me to 1. My y's, I'm multiplying by 2, so my 4 would go up to 8. So this point would translate to right here. And then, either way, we're going to get the exact same answers. Okay, so this point, I'm going to pick this point at 0, 0, is negative 7 and 2. So this is nice and neat. 7 units, and I've gone up 2. Exactly. So let's look and see if it worked on this one up here. I'm at 1 and trying to get to negative 6 and 10. So if this point here left, and I was at 8 and I need to go up to 10, so that's going to be up 2. So it doesn't matter which way you do. All right, so let's put this in. So really, mathematically, this means my C value is a negative 7, and my D value is a positive 2. All right, so let's put that into this form right here. So we have y equals, my A value is 2, then my fancy F, and then bracket my B value is 4, x minus negative 7 plus 2. And so we're just going to tighten that up a little bit. Okay, so a couple of quick things here. If you don't have these inner brackets, you're going to have to common factor to get that B value out for you to see it. Does that make sense to everybody? Like if I gave you this, y equals 2f bracket 4x plus 7 plus 2, these are not the same thing. They're not the same. Because that 4 would have to leapfrog in, and that one would be a 28, right? So if I gave it to you like this, you're going to have to common factor that 4 out, which would be 2f4 bracket x plus 7 over 4 plus 2. Very different now, all of a sudden. So this and this are not the same thing. If I give it to you like this, you have to common factor that 4 out. Yeah, bad, oh bad. Okay, I can't hit pause, but I would like you guys to do the transformations. And so f of x is your original, and g of x is your translated or your image graph. All right, do your worst. Give it to me in function notation. Again, you haven't been given the exact equation of this, so we're just going to simply do it in function notation.
I have a question about one of our things from yesterday that I think would come and help me understand a bit.
Sure. They even left me a voicemail, those people. Jeez Louise. Yeah. That.
Do you want to present a bit?
Yeah.
So, when I ask you to do that, do the APB.
Okay. So determine the equation of the image if the function is vertically stretched by 4. Absolutely. But we would put it on the y. So we have y equals. Okay.
And then you want to test the band. Like that?
Yeah. Exactly. Yeah.
I was working on this yesterday and I saw that x squared, which I feel like I'm doing something right, but I feel like before I continue going.
Absolutely. All right. I'm just going to pop in here and you guys can keep going if you're going, and I'm just going to pop in for a second. And you guys see the translated points? You guys caught those? The translated points? How'd you guys do?
Stretching the X.
But remember, you're looking, this has a width between those 2 points of 2, and between these 2 points now has a width of 1, 2, 3, 4. So I knew, that's why those translated points are really important. Because if you looked at that graph, it's like, this didn't translate.
I
There's,
just couldn't see anything good.
it's a subtraction sign. Right, because I'm going right 3, so I'm doing the opposite. Did you guys get the, oh, I wrote that there's a reflection. What didn't I do? I didn't put it in my equation.
You put a negative on the
I gotta put a negative
front of the.
in front of that 3, because a reflection in the X means that I'm multiplying my Y's. I wrote it down and then I didn't do anything with it.
So, because I can't really see what you wrote, it's y equals negative 3f 2.
Nope,
No?
1/2,
Oh, okay.
right? Because if I'm multiplying by 2, I'm putting the reciprocal in. And then bracket,
X take away 3.
yep,
Then another set of brackets.
2 sets of brackets, yep.
Take away 4.
Take away 4, yep.
Got that right.
And again, please make sure you're closing the brackets. It seems like such a small thing to do. This bracket here, I've opened, so I close it, open, close. So you do need those 2. I know it feels weird, but yeah, you do have to do that. And we're doing it in function notation because there's been no function given to us. I think we could all probably figure out what the equation of this is, right? This one's y equals x squared, but I don't need it because I can just do it based off function notation. Okay, last question. Is this one. You have a point on the parent graph, so the original graph is 4, 3. You apply the transformations of this. What are the coordinates of the transformed point? So it's not asking you to graph, it's giving you a specific point. So right away, this is the folly before we get going. Please note that the negative 2 hasn't been removed. It's not in its own separate brackets. So that's going to be the first thing that I'm going to do. Is I'm going to common factor out that negative 2. And if you're not comfortable with common factoring, really what I've done is I've divided each term by negative 2. And I just put that negative 2 outside. So if common factoring doesn't make you feel comfortable yet, it's just that division. So now I can go ahead and do things. So let's talk about what's happening to the y's. What am I doing to my y values?
You're flipping
So they're timesed
by negative 3.
by negative 3,
And then add.
and then we're going to add 2. And then what are we doing to the x values? Who? Beauty. So we're going to times them, well, that's supposed to be an s, times by negative 1/2, and we are going to add 2. Because there's my add 2 for the x's, there's my negative 1/2, right? So the x's never do what we want them to do, or what we think they should do. They're always opposite. Okay, so really, we're gonna take our original points. My original point was 4, 3, and we're just gonna map it. What does it transform into? My x's have to be multiplied by a -1/2 and then add 2. So if I take 4 and times it by, because order of operations says I do my multiplying first, so times by -1/2 gives me a -2, and then I'm going to add 2, which brings me to hopefully 0. Okay, y values, first thing I do is I times by the -3, so 3 times by -3 gives me -9, and then add 2,
-7.
that's it. So I guess the biggest thing for this one's definitely a little bit challenging. This one here is pretty easy, but just remember to always do your multiply first, and then do your adding second. Like, that's the big part on that one.